Welcome back. This is tutorial 6A question 1A. We're asked to find the DTFS of this sequence. So it is obvious that this sequence x of n is equal to x of small little n plus 4. The period is 4. It repeats every 4 samples and the values are 0, 1, 2, 3 for the given index here. So what we do is that we are going to use this equation for DTFS, and therefore the k will now go from 0 to 3, and here of course is 0 to 3 for n minus 1. Now the values of xn is 0, 1, 2, 3, and now we can actually compute this by hand because this is relatively simple, and this is the answer for the 4 coefficients C0, C1, C2, C3. Now if you compute this in rectangular form, which is okay, but we prefer you to write it in the polar form. The polar form of this number is, so I'll use MATLAB and I type in this number, minus half plus j times half, and then I get absolute value. So this is 0.7071, and if I type angle, it's 2.35. So I should now write it here. So you notice that I write it in this form. This form is called the polar form. This is the magnitude and this is the phase. And you'll see that actually there's a very close relationship between these two, because this is the conjugate of this, and therefore the magnitude is the same and the phase is actually inverted. Okay, and now what about minus half? So minus half, if you want to write in polar notation, you have to write the magnitude, and the phase you can write this, or half minus pi. Now I'm going to use MATLAB to compute for you, and in MATLAB the idea is this: you can write this equation, x equals to FFT of 0, 1, 2, 3, and you have to do 1 over 4 because 1 over 4 is 1 over n, and this FFT is actually doing DFT, and DFT is actually this equation here, n minus 1 x of n e minus j 2 pi over n kn. Alright, so let's see the results of MATLAB. x equals to 1 over 4 times FFT of 0, 1, 2, 3. And the answer is all these values here, and I want to put absolute value of x. Then you get 1.5, 0.7071, 0.5, and 0.7071. Now I want to get the angle of x, and you'll see the first one is 0, second one is plus 2.35, third one is pi, fourth one is minus 2.35. So these are the what do you call that? The complex conjugate. So the angle is opposite or negative of each other. So to use MATLAB, I'm going to use MATLAB. This is the code over here, but basically it is nothing but 1 over n FFT of that sequence, and this is the answer. Typically, we use capital X to represent the frequency domain and small x to represent the time domain. So this is the answer, and the answer given is in rectangular form. We use absolute, we'll get the magnitude, and if you angle, we'll get the phase. Right, now we then can plot the magnitude and the phase spectrum. In here, I'm going to plot k times 2 pi over 4. So this is k equals to 0, 1, 2, 3, and you'll realize that 2 pi over 4 is 0.5 pi. So this is 0.5 pi. Okay, so typically you are going to say this value is C0, C1, C2, C3, and this is the magnitude value, and this is the angle. So let's see. The first value is 1.5, second value is 0.7071, third value is 0.5, and the fourth value is 0.7071. So this is the 4 magnitudes C0 to C3. The angle, the first value is C0, the angle is here. Second one is 2.3 is here. Third one is minus, I'm plotting pi here because actually minus pi and pi is the same, and the fourth one is here. Again, remember that this, you can plot this as omega in radian per sample, or you can plot it as k. So this is 0, 1, 2, 3k. That's all for this question. Thank you.